Welcome to Maths with Bob. This is the 3-minute series on growth and decay. We're looking at a decay problem here, similar to an earlier one, but this time we're looking at the rate of decrease of this particular isotope. We are told that you can see here the mass of the isotope decreases by 15% in 30 years, and then we have to find out what is the rate of decrease after 100 years. And you notice we don't know what the actual original mass was here. Let's see how we do this one. Okay, so first thing, obviously, we go through and assume that the initial mass is m0. Now it's obviously exponential growth and decay. So we're assuming a solution m equals m0 e to the kt. And we go through and substitute in these values. T is 30. It's decreased by 15%, so it's only 85% present. Okay, and then we just quickly go through this. But basically, it's similar to the earlier video, but we're now looking at a rate as opposed to a particular, a time, if you like, for the mass to, or I think the original was half-life. I think the original problem was. But okay, 0.85, okay, m0 equals m0 e to the 30 times being 30 years. You can see divide by m0. We end up with 0.85 equals e to the 30k. We need to solve for k, take the logs, bring down the 30k, and then eventually get the decay constant. Now notice this is negative. ln 0.85 is actually negative. Okay, so we keep it in the exact form. You can see here, always keep the constant in the exact form. Okay, so what do we do now? Well, okay, we've got the constant. Okay, this is actually a, well, I should say this is actually a, okay, actually that's actually a decay constant actually, but anyway. All right, so what do we do now? Well, after 100 years, we need to work out what its rate of decreasing is. First of all, we need the rate, I guess you could say. Okay, so what do we do first? Well, obviously, this is our solution. M equals m0 e to the kt. And we have to, you can see here, we need to differentiate m, dm dt, and obviously just the k will come down from the differentiation of the exponentials. Okay. So it's k m0 e to the kt. We do know k, we don't know m0. We don't know what the rate is at the moment, and we know the time is 100, and we know k is the constant. Okay, constant over here that we found before. Okay, so what are we going to do? Well, we are obviously going to substitute everything in to the dm dt. Here it is. Okay, let's put it all in. Put the time as you can see time is 100 over here, and we try and work out what this does to m0. Well, when we have a look at it, we can see here dm dt is actually minus 0.0031514 ... times m0. Okay, so it's decreasing at less than 1% actually after 100 years. You can see here it's actually about decreasing at a rate of about 0.13, well, 0.315%, so it's obviously quite a bit less than 1% after 100 years. Okay, well, thank you for watching, and bye for now.